Have you ever wondered how Kubernetes manages traffic to your applications? It's a complex system, but today we're breaking down the kube-proxy mechanism to help you understand it better. I get it. When you're deploying applications across multiple nodes, it can be confusing to know how traffic is routed. You're not alone in this. Many developers face similar questions about Kubernetes networking. Let's dive into a specific question from a user. They asked, when I expose my pods as a service, are all nodes in the cluster configured the same way? This is a great question and one that many people have. To understand this, we need to look at how kube-proxy works. Kube-proxy runs on each node and watches the API server. It builds IP tables rules that reference the portal IP chosen by the API server. This ensures that traffic can be routed correctly, regardless of which node the client connects to. Stay with me. At the end of this video, I'll share a pro tip that can help you optimize your Kubernetes services even further. To understand the kube-proxy mechanism in Kubernetes, the user should first know that kube-proxy runs on every node in the cluster. It watches the Kubernetes API server for changes to services and endpoints. When the user exposes pods as a service using the command kubectl expose, kube-proxy on each node creates IP tables rules. These rules are essential for routing traffic to the correct pod. The user is correct that kube-proxy needs to configure these rules on all nodes. This is because any client in the cluster could connect from any node to the service's portal IP. Finally, the user should note that the portal IP is chosen by the API server. Kube-proxy uses this IP to ensure that requests are properly routed to the available pods, regardless of the node they reside on. Fun fact, Kubernetes was originally developed by Google, and it's named after the Greek word for helmsman or pilot. Just like a helmsman steers a ship, kube-proxy steers traffic to your applications. Now let's look at the answers provided by other users. This user confirms that you are correct. The portal network, also known as the service network, is managed by kube-proxy through IP tables rules. Each node in the cluster must have these rules because any pod on any node can connect to any portal IP. For more detailed information, you can visit the Kubernetes documentation on virtual IPs and service proxies. Here's that pro tip I promised. Regularly review your kube-proxy configurations and IP tables rules. This can help you optimize performance and troubleshoot issues before they become major problems. And there you have it. Understanding kube-proxy is essential for managing your Kubernetes services effectively. If you found this video helpful, please subscribe for more insights, and don't forget to check out our next video for advanced Kubernetes tips.